This video will serve as a tutorial on how to carry out thermal analysis via Differential Scanning Calorimetry, or DSC. The protocol followed in this video is the same as the first part of the DSC pre-experiment outlined in your lab syllabus. Differential Scanning Calorimetry, or DSC, is a thermoanalytical technique in which the difference in the amount of heat required to increase the temperature of a sample and a reference is measured as a function of temperature. In other words, the DSC measures the amount of energy absorbed or released by a sample when it is heated or cooled in relation to a reference. The DSC in the lab that will be utilized in this experiment is a heat flux instrument as opposed to a heat flow instrument. Both instruments are fairly similar and truly only differ in their construction and their principle of measurement. In the heat flux instrument, as the one we will be using in the lab, the temperature is allowed to vary and the signal is converted to heat flow. The results from both instruments are also fairly similar and only differ in the direction that their transition peaks go. DSC curves are visualized as a function of heat flow on the y-axis and either temperature or time on the x-axis. For a heat flux DSC curve, as the one seen here, exothermic reactions are indicated by a rising or positive peak, whereas endothermic reactions are indicated by a falling or negative peak. In a heat flow DSC peak, the direction of the curves would be reversed. To prepare your sample, you will need the pan and pan lids, crimper, and forceps, as well as your sample, in this case indium metal. You first want to weigh out your sample. First, tear out a single pan on the analytical balance, and then weigh out between 3 to 5 milligrams of your sample. One way of making this slightly easier to manage is to place some of your sample onto a half-folded piece of weigh paper and to carefully scrape or brush it off into the pan. Once you have your sample weighed out, place the pan in the crimper holder and place a single lid on the top of the pan. Make sure that you only have a single lid as they get stuck together easily. Once the pan is in place the crimper holder into the crimper and turn the handle until you feel slight resistance. Once you feel this resistance, turn the handle another 360 degrees. Finally, loosen the handle on the crimper to release the holder in the pan, and inspect the pan to make sure the lid has a tight seal. You will also want to create an empty reference pan in the same manner as mentioned before. However, this pan will have no sample in it. Make sure that you distinguish the two pans apart from one another in some way. Be sure to turn on the nitrogen gas and to make sure that the pressure is at 15 psi. Open the sample chamber on the machine and remove both internal lids. Note that there is an S and an R written on the side above the sample chamber. This indicates which side of the sample chamber the sample and the reference go in. Place your pans into their respective sides of the sample chamber. And then replace the internal lids securely and close the sample chamber. On the analysis desktop, open the icon that is labeled TA60WS Collection, and then click on the DSC60 icon in the detector window. Click on the Measure drop-down menu in the menu bar and choose Measuring Parameters. Under Temperature Program, you can input your parameters for your temperature and ramp rates. For this experiment, you will want to set a rate as 10 degrees Celsius per minute, the hold temperature as 200 degrees Celsius, and the hold time for 1 minute. Also make sure that 1 has a check mark under it in the gas column. Next, click the File Information tab and input your information into the respective fields. Make sure that you specify that you are using an aluminum pan, the sample weight, the atmosphere being nitrogen, and the flow rate being 20 mils per minute. You can leave the lot number, molecular weight, and the comment boxes blank. When you're finished, click OK. Click on the Start button in the upper left-hand corner of your screen. The Start menu should appear. Make sure to set your destination folder to your respective folder on the T drive. Once you are done, click Start. You should hear a loud click from the DSC instrument, and the screen will turn from blue to red. This indicates that your analysis has started. Try to minimize vibrations on or around the bench that the DSC is on at all times, as it can have a slight effect on the results. Once your analysis is finished running, you can analyze your results. On the analysis desktop, open the icon that is labeled TA60 Data Analysis. Once here, go to File, Open, and go to your respective folder and open your data file. You should have a DSC curve that is similar to the one seen here. You can get rid of the temperature line by right-clicking on it and pressing the radio button in the first column that is labeled None. You can then baseline correct your data curve by clicking on it, clicking on the drop-down bar labeled Manipulate, and going to Baseline Correct Manual. From here, you want to click at points on your data line to flatten the line. Finally, click OK. Next, you can analyze your peaks by clicking on the first of the bottom center icons labeled DSC Peak. Click on either side of your peak, where it begins and ends. 2 blue vertical lines will appear. Click Analyze, and the peak, onset, and ending temperatures will appear, along with other analysis parameters. You can then do this for all of your peaks. Once you are finished analyzing all of your peaks and making your graph look nice, you can save it as a PDF and export the file.